Welcome to our unit on probability. This first section is just going over some of the basics and a little bit of vocabulary that we'll be using. Probability is a numerical measure that indicates the likelihood of an event. All probabilities are between 0 and 1, 0 and 100% if you'd like. A probability of 0 means the event is impossible. A probability of 1 or 100% means it's certain to occur. And then the closer you are to 1 or 100%, the more likely that thing is to occur. We're going to talk about 3 different ways to talk about probability. The first one is intuition, then relative frequency, then equally likely outcomes. The first one, assignment by intuition. This is something that you just kind of throw out a number based on your experience or based on your judgment. So an example might be based on a previous year's sales and the manager's projections, the chances of selling 100 televisions the Friday after Thanksgiving is 75%. He doesn't know this for sure. He's just thinking back to last year and thinking about how this year is going and just making sort of his own educated guess about what the probability will be this year. That's assignment by intuition. Assignment by relative frequency, sometimes I call this experimental probability. If that manager had looked at last year's sales and just used that number and not factored in anything else, that would be a relative frequency because we're just looking at what actually happened in the past. So we're going to take F, the frequency of the event, over N, the sample size, which sounds a little complicated, but here's an example. We flip a fair penny 200 times, and heads comes up 104 times. If we were going to say what the probability of flipping heads was, we wouldn't say 50-50 if we were using relative frequency. We would say 104 out of 200. It's an experimental probability. If you note that 57 of the last 100 applicants for a job have been female, you might say that the probability that the next applicant is female would be 57 out of 100. Relative frequency is just taking what's occurred in the past and using that as the probability of what will happen next. The law of large numbers is related to that. As the sample size increases, the relative frequency gets closer and closer to theoretical probability. So a good thing to look at is like the coin toss. If you flip a coin 200 times, you might get 104 heads. But if you flip it 500 times, you might get 259. The moral of the story is that the more times you flip the coin, the closer your experimental probability should get to that perfect 50-50 that we know a coin has. And that sort of relates to when we talked about taking samples of a population. The bigger your sample is, the closer you're going to get to estimating that population parameter. And finally, the third type of probability, called assignment for equally likely outcomes. I often just call this theoretical probability. It's just the mathematical, the calculated probability. Equally likely outcome just means that no one event is expected to occur more frequently than another. So we're talking about rolling dice and flipping coins. And again, the probability is just the number of outcomes favorable to event A over the total number of outcomes. That probably sounds more complicated than it needs to. If we roll a 6-sided fair die, we would say the number of outcomes would be 6. And the number of outcomes favorable to event A, well, if I were looking for a probability of rolling a 3, how many of those outcomes are favorable for rolling a 3? Just 1. And so we would say that the probability of rolling a 3 is 1 out of 6. Rolling an even number, the probability I've got 1, 2, 3 even numbers out of 6 total outcomes. You can reduce that. You can write it as a decimal or as a percent. Totally up to you. And then the probability of rolling a 4 or a 5. How many outcomes would be favorable to that? These 2 would be favorable to that. So there are 2 favorable outcomes out of the 6 total outcomes. All of these examples have really been statistical experiments. It's a random activity that results in a definite outcome. So an example of a statistical experiment might be flipping a coin and rolling a die at the same time. An event is a collection of one or more outcomes in the experiment. So maybe an example of an event would be flipping heads and rolling an even number. A simple event would be an event that consists of exactly one outcome in a statistical experiment. So maybe not flipping heads and rolling an even, but flipping heads and rolling a 2. That would be more of a simple event. And then the sample space is just if you listed the set of all simple events. Let's do an example. So we're flipping a coin and rolling a die. What is our sample space? I like to use this set notation where we use curly brackets because we'll describe the set of all simple events that could happen. So flipping a coin, we could get a head and we could roll a 1. Or we could get a head and we could roll a 2. Or a head and roll a 3. And so the sample space is just where we list all of those combinations. Our sample space has a list of every simple event, so each of those would be considered a simple event. Heads and a 1, heads and a 2, tails and a 6, those are all simple events. So now let's do some examples. Flipping a head, we would go back to our sample space and we would decide how many of those included flipping a head. And then to find the probability of head, we would take how many of those we counted. There were 6 of them that included that event out of the 12. And that would be our probability. The next one, rolling an even, you'd have to go through and find out which of those simple events had an even number rolled. And it turns out that it's 6 of them, so the probability of rolling an even would be 6 out of the 12, again 1/2. Rolling a 5, we know that a 5 is rolled in 2 of those simple events, so rolling a 5, the probability would be 2 out of 12. And finally, flipping a tail and rolling a number less than 3. Well, we've already narrowed it down to just those tail outcomes, and a number less than 3 narrows it down to just those 2. And so you can see that you could list out those events, which gives us a probability again of 2 out of 12. Let's go over some probability rules. The sum of the probabilities of all the simple events in the sample space must equal 1. So we could say if we were rolling a die, the sample space would be the set of rolling a 1, 2, 3, 4, 5, and a 6. And each of those simple events has its probability, a 1 out of 6 chance. And this probability rule just says that if you take the probability of each of those events, the sum of all of those probabilities will always equal 1, because you're guaranteed that one of those is going to happen. We're going to talk a lot about complements when we talk about probability. The complement rule. The sum of the probability of a simple event and the probability of its complement must equal 1. A complement is just the opposite. So if the event was it rains tomorrow, the complement would be it doesn't rain tomorrow. If the event was I win $1 million, the complement would be I don't win $1 million. And this rule just says that if you add the probability of something happening plus the probability of that thing not happening, you should always get 1 or 100%. Either it happens or it doesn't. There's some special notation that we use. Let's say that we used A to stand for the event that it's raining. Then A with a little superscript of a C, a complement, would be not raining. And we can say that the probability that it doesn't rain is 1 minus the probability that it does rain. That probably seems more complicated than it needs to. Let's say there was a 44% chance of it raining. We would say there is a 56% chance of it not raining. The sum of those two would be 100%. The sum of an event and its complement must equal 1.